showing it as best I can without being exactly specific because I don't want any argument. So it's somewhere down there, it's the last ring. If I point anything near the crotch there, that's got to be carina. Okay, now let's go. This one's going to be right, this one's going to be left. Primary, primary, first one. Bronchus. Oh, no, bronus. It's a C. Bronchus. So left and right, primary bronchus, plural is bronchi. That's why it says point where trachea branches into two bronchi. Left and right bronchus, though. This is not a bronchi. I get that so much. It's not a bronchi, that's a bronchus. Yeah, I know it's weird, and why does it matter? But oh, look at those four dogs over there. I mean, you sound dumb not saying the right plural form. It sounds weird to people who know. Okay, what now? What are we going to do now? Oh my God. Yeah, where's the primary? Where's the, right here probably? Two primaries. Who's this up here? Trachea probably. And then, oh my God, what happens? How many times do we branch? 23 orders of branching. This is going to say it wrong there. 23 orders of branching. There's no way we're going to learn all those. So let's just go a teeny bit further and then skip to the end. It's called the bronchial tree, respiratory tree. It's like an upside down tree or a root system to me. This is what your lungs would look like if you could get rid of all the muck and just look at the tubes. Okay, so respiratory tree, no problem. All right, so let me draw what's important here. You got two primary bronchi, we just spotted them. How many do you guess we're going to have in a moment? Like when they split, they're going to be secondary, but how many? How many would you expect? I would expect 4, right? 2 and 2, but it's not going to do that. So here's the trick. You do have secondaries. There's 3 of them on the right side and 2 on the left. There are 5 secondary bronchi, not 4. So here's a secondary, here's bronchus, secondary bronchus, secondary bronchus, secondary bronchus, secondary bronchus. There are the 5 secondary bronchi. 3 on the right, 2 on the left. Secondaries. That's as far as we're going to go. You can keep going tertiary and quaternary and 5, 6, 7, 8, 9, 10, 21, 22, 23, and we're way down there. We're going to skip all the way to the end. But it keeps branching and branching and branching and branching and branching. Why is there 3 and 2?
3 lobes.
Yeah, these are also called these secondary bronchi. You can call them secondary, but they're also called lobar bronchi. Lobar, if you hear the term lobar bronchi, that means it's one of those 5 secondary branches. Lobar bronchi, because the reason she just said, we got to go to the lobes, and there happen to be 5 lobes of the lung. 3 lobes on the right and 2 lobes on the left. So that's why they're called lobar bronchi. They branch into the lobes. So the 2 primaries, I mean, if you wanted to draw where the lungs are here, I mean, it's like right here. We're going into the lungs in the primary. And then once we're inside, we need to branch to the lobes. 3 over here and 2 over there. And then we'll branch and branch and branch and branch and branch and branch and branch. At some point, we'll get down to the end of the line, and that's where we're going to start. It's hard to even see where the secondaries are here. I think there's one here, and I think there's one here. And I think there's one here, and I think there's one here, and I think there's one here. But I don't know for sure. It's too messy. So I won't show you anything like this on a test. But, I mean, that's easy to deal with. 2 main ones, and then 5 secondary. 3 on the right, 2 on the left. That's easy to deal with. Okay. And that's what it says right here. Trachea splits in the right and left primaries. And then each primary bronchus enters the lung, where each branches into secondary, aka lobars. Remember, there are 5 lobars, 3 on the right, 2 on the left. There's the highlights. I just showed you that. And then we branch again, tertiary, and again, 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 and again. At some point, I don't know the number, they're called bronchioles. Just like arteries become arterioles when they get really tiny. These bronchi, at some point, become bronchioles. And then we get to the end, the terminus. You see terminal bronchioles, the teeniest ones. I don't know if that's the 23rd order or the 22nd. I've never figured that out all the way. You don't have to either, but it's down there at the end. According to my pictures and the ones in the book, that would be 22, but I'm not going to fight it. So there we go. 2 primaries, 5 lobers or 5 secondaries, 3 on the right, 2 on the left, and then branch, 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 branch to get into little teeny bronchioles, and then teeny tiny, itsy bitsy terminal bronchioles. Okay, let's name the lobes. They're super simple. First of all, I know there's 3 lobes over here, so I'm going to have 2 cracks on this side. I know there's 2 lobes over here, so I'm going to have 1 crack on that side. So we got to know the names of the cracks. So this one, even though it's kind of droopy, it does go across, so we're just going to call it horizontal. No, it's not quite horizontal. Fissure, I think is what it's called. Horizontal fissure. I bet you could call it transverse and get away with it, but that's the only term I've ever heard for it. If you put a term on the test and you're sure it's right, and you can Google it and prove it to me, I'll take it. But I'm going to call it horizontal fissure. You don't have to call it right horizontal fissure, because there's not one on the left. That implies, if you say horizontal fissure, you're implying you're on the right side. Just making sure, right, left. It's not like the heart, well it is, but you don't have to play that game all the time. These are diagonals. What's the word for diagonal? Let's try that again. What's the word for a diagonal cut? Oh, no. Oblique. So these are the 2 obliques, left and right oblique fissures. That would be the right oblique fissure and the left oblique fissure. There's only one horizontal, that's on the right. The 2 others are the obliques. You just name it on the side, right oblique, left oblique fissure. You can call it crack for all I give it down. Notice one of them has a bite taken out of it. This is why the left one is smaller and only has 2. Why does it have that? Now the heart, remember 2/3 of the heart is on the left side, so we have to get some room for it. Because when that heart beats, it twists, and it's got a lot of action going. We have to facilitate its action. So this is simply called a cardiac notch. Split the word up, but I think we got the word cardiac already. Cardiac. It's like Cadillac notch. It's more expensive. Cardiac notch. Facilitate heart action. The lobe names are like super cheese ball, so let's practice it real quick, make sure we got it. It's just up, middle, right, down. I mean, the top one. Superior, right. Hey, that's easy. Inferior, I mean, it tells you that already, but inferior, right, middle, right, easy. The other one doesn't have a middle. That's even easier. It's just superior left, lobe, and inferior left, lobe. It's already labeled here, but that's it. It's really easy. 2 lungs, 3 cracks, 5 lobes, 3 on the right, 2 on the left. Super easy. Everyone, no one has to study this very much. It's the digestion part that's hard. Okay. We're almost done. We're almost done today. Hallelujah. Let's see if I can get done before 4. End of the line. Remember, skip, 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 skip. We saw the primaries 2. We saw the secondaries 5. And then break, branch, tertiary, quaternary, and on and on and on and on and on. So we get to the end of the line at some point. We're downtown here, so let's draw this. Beautiful. How beautiful is it? Super beautiful. There we go. Balls. Sticks and balls as usual. It's like a sack of grapes. And now we're down here somewhere. Trying to draw some of this stuff, but your book says this is the terminal bronchiole. This little guy. Which begs the question, there's another branch, so that's what I'm saying. Is that 22 or 23? Don't know. But this one going in here that plugs in the grapes, this is called a respiratory bronchiole. Both bronchioles, that fatter one's the terminal. It's not actually the terminal. There's another one. And these little balls here, one of them is called an alveolus, which literally means cavity. Think of them as tennis balls. Because if you open a tennis ball, what's inside? Air. And not nothing, there would be a black hole. There's air inside. Just like these guys, in a very thin rim, right? Very thin rim of rubber. Oh, like basketball, same analogy. A little thin rim of rubber with air inside. It's not like a golf ball, or a baseball, which got a solid center. These are just little thin rims of cells with air inside. Plural is there, alveoli. That's how you usually refer to them, as alveoli or alveoli. Potato, potato. Multiple alveolus. Okay, what happens in these alveolus? Exchange. That's it. What's being exchanged here? CO2 with O2 usually. Back and forth and back and forth and back and forth. So that's the point. It says that up there. 300 million or so account for most of the weight of the lungs, and this is where exchange occurs. That's lots of it we got. Okay, they do wear out over time, like everything else. Okay, something that's often added to pictures of this is little ribbon-like hairs that wrap around these tubes. They look like ribbons to me. You can probably see them better in the real image. They look like red ribbons wrapped around it. These bronchioles, again, there's no cartilage down at this point, or you wouldn't be able to move them. But there's no, we didn't talk about a wall structure, like on an artery that can push itself. These don't have that. They're not like arteries or veins. Instead of being able to have squeezy layers, they have squeezy muscle wrapped around them. So these are smooth muscle wraps. I don't know, I can't remember a name for them, so I'm just going to call them smooth muscles. I'm sure there is a name. So they're wrapped around like ribbons. And if these smooth muscles squeeze, they're going to squish this bronchiole, right? They're going to squeeze it down. So what's the word for that? Not vasoconstriction, but probably bronchoconstriction. If I can fit it. Really? Bronchoconstriction instead of vasoconstriction. And they could be, bronchodilation instead of vasodilation, right? So that's what allows people with asthma, these things are squeezed down so much they can't get air out. It's hard to breathe out. And then if you can't breathe out, you can't breathe in again. COPD, things like that, they have gunk in here, and the air won't flow past the gunk. Emphysema, they have these things either shriveled up or popped open where there's no exchange going on. So a lot of these respiratory problems, they happen right down here at the bottom of the line. All the stuff up top here, those tubes are so big, you don't really have much of a problem at all. We'll see in a minute when you get to the physiology. I guess a week. Okay, there's the pretty picture I tried to draw, but they drew it better because they got paid more to do it. So there is the end of the line. And then here's getting up close and pretty. I really like that picture there. I'll just do it again just so you see it. You see the alveolus, each one. And then I like the way they have like this red network on one side and then the blue network on the other side. I just think that looks really good. And it's showing you that there's exchange happening there. It's a very good image of that. So you can picture each of these balls wrapped around, capillary nets wrapped around them. And this is where the respiratory system and the cardiovascular system touch each other. So we're bringing in CO2 and putting them in and it's blowing it out. We're breathing in oxygen and putting it in the blood. And back on. I like the honeycomb picture here. Shows them cut open so you can see that they're hollow inside with a little thin ring, just like a tennis ball or a basketball. It's like a honeycomb to me. And then we can jump way inside one, like right here. Let's jump way inside. This will be pretty much the last little thing we'll do today. So let's get inside of one of the balls, because as far as anatomy goes, there's nowhere to go beyond here. This is where it's exchange. This is the end of the line. So very thin, yeah, okay. I don't see it. Oh, I see it. So let's just do a single cell thick. That's how thin. Single cell. Anytime you have a row of single cells, it's probably for exchange, right? And it is again, because I know we're doing exchange here. So again, you don't want to exchange to the Great Wall of China. It's too thick. So the key word here is going to be diffusion. I know I see it down there, but hey, there it is. Very thin walls. single cell thick, allows diffusion. Okay, that's what an alveoli is. Show we some structures here. The first thing is pores. I can see them pretty clearly here. You might not on your little teeny picture, but there's one. There's one. There's one. There's little holes here. There's holes connecting them all, and it's exactly what you might think for this pressure equalization. Yeah, so they're all connected. So if one's about to blow out, it can push the pressure next door, and you won't have a blowout. It's just a pressure valve. They're all connected together. So there's pores that allow you to pressurize the system, so you don't blow them all out the first few breaths you take. Okay. Macrophages, and if it doesn't say their name, I'm not going to tell you them. I'm just going to pretend I don't know. There's macrophages in here, right? Big eater cells. There's the little puffball guys here, little mop heads. They're walking around inside, eating fast crap. That's what they do. That's what phagocytes do. Macrophages walk around and eat stuff. So there's there's macrophages inside your lungs, crawling around inside the alveoli, cleaning up all the crud that you breathed in during the day. As far as the alveoli themselves, they're made of two types of cells, type 1 and type 2. I can see them here very simply. Most of the cells you see here are these little tan colored with purple nuclei. That's type 1s. And I'll just show you right there. These are all type 1s. They're epithelial. It says this in the notes, but I'll just write it here. They're epithelial cells. And this is diffusion. So I'll just put diffusion. Fusionary epithelial. Okay, there's a diffusionary epithelial membrane. And it shows it right here in this picture. It's saying, hey, this is where we're doing diffusion. So these type 1 cells, to the capillary, we're just doing the exchange right there. You see the blood vessels even running in between all the little balls there. So nice close-up shot here. We see the mop heads, we see the pores, we see the type 1 cells. So what's left? The type 2s. The type 2s are those green guys. Very few of them. These are actually cells that are part of the wall. Another little one, these are called surfactant cells. Let's see what they call them in the notes. Yeah, I don't care that they're cuboid. They're surfactant cells. That's what you need to know. So most of the walls of the alveoli are type 1 cells, which basically make up the diffusionary wall. That's most of the cells of these little type 1 epithelial cells. But these dudes here are also epithelial, but they're cuboidal. Don't really care, but it's called surfactant cells. So let me tell you what they do. They drop surface tension. And it's going to say this later, but I'm just going to put the note there. Drop surface tension. I'll kind of explain that later and why that's important. If it didn't do that, none of us could breathe right now. Or we grow underwater for 10 months, and then we're forced out here into this breathing world, and the lungs do not like that very much at first. So we got to counteract that tension. I'll explain it better later, but hey, there you go. Pores, mop heads, type 1 cells for diffusion, type 2 cells for surfactant making. That's it. That's your alveoli. Okay, a few more little ding-dings here. Which I think we've got it all. The only thing, I don't care about base and apex. We don't need all that, but we did the cardiac notch, right? Check. We did the cracks, right? I'm just reading to make sure we told you the same words. And the lobes. There we go. Then they've done that. Here's cardiac notch, just in case you're napping. That's a big one. There you go. What's right underneath here? Maybe the diaphragm, right? It's going to be the major player when you're trying to breathe in, breathe out. We need that diaphragm to be pulling those things down. But we'll get into that next time. Oh, I don't want to do that at all. So it's not. Okay, that gets into the physiology. So next week we won't even mess with this. We're just going to test next week, so now I'm going to go over those tests. And you can stay here and practice if you need to or whatever. It's not quite like the same test one where you have a nice chart and everything. It's not like that. So